Welcome to today's math lesson. Go ahead and pause the video and set up your journal so that it says thousandths with lesson 2.2. Put the date in the box, and you will need all of these colors today. So push pause on the video and go find red, orange, yellow, green, blue, purple, pink, and black. And of course you'll need a pencil. Once you found all these colors, you should have written the title thousandths, and you should have written this number 4,692 and 735 thousandths. That is how you say that number. Again, 4,692 and 735 thousandths. Okay? We're going to be talking today about the thousandths place value, which this is the tenths, this is the hundredths, and the third place over to the right of the decimal is the thousandths. Okay? We're going to name each place value and what color that they are assigned to. So the first thing we're going to do is keep red out, and I would like us to skip a couple lines, and let's come down maybe about 5 or 6 lines, and then I'm going to make a red square, and I'm going to make a key here, meaning the number that is red stands for the thousand place. And usually put an S on the end of that so that it says thousands. The number that is in orange, so we're making a key, which means another box but underneath it. The number that is orange is the hundreds. This should not be new information. We're just reviewing it quickly. So we have thousands, hundreds. Do you know what this place value is? It's the tens. Again, trying to make a box to represent the tens place value. And which place value is to the right of the tens and to the left of the decimal? What place value is that 2 in right now? Think about it. You can say the answer out loud if you know it. What place value is that 2 in? It is in the ones place value. The ones place value. So we have the ones, the tens, hundreds, thousands. Again, ones, tens, hundreds, thousands. What's super interesting right here on the decimal, make sure that you've put a black box around it. Super interesting. Any number that is to the left of the decimal, each of those place values is 10 times bigger each step you take to the left. I think that is worth writing about. So we'll say each place, well, let's say each place value. Each place value is 10 times bigger for each step you take to the left. So what that means is here at the ones place value, if I take a step to the left, I'm getting 10 times bigger because 1 times 10 is 10. See, look at my finger, my left finger here. Ones place value, step to the left, it's 10 times bigger. 1 times 10 is 10. What is 10 times 10 as you step to the left? It's 100. What is 100 times 10 as you step to the left? It's 1,000. So that's how the base 10 place value system works. Is right here at the decimal, everything to the left are wholes and everything to the right are pieces. So my wholes are this. 4,692. It could be dollars. It could be goldfish. It could be crayons. Whatever whole things you have, it could be 4,692. And then what are these to the right of the decimals? What are these? They are pieces. So we have wholes and pieces. So just like each time you step to the left here, it's getting bigger. What do you think happens as you step to the right after the decimal? That decimal is really powerful. It's where everything shifts instead of going left and getting bigger. When we step to the right here, it is getting 10 times smaller each step you take. No matter which direction, even if I started clear over here, as I move to the right from tens to ones, it's getting 10 times smaller. So is it from ones to the tenths. It's getting 10 times smaller. So we need to write that. Each place value is 10 times smaller for each step you take to the right. I'm going to write that whole thing. Each place value is 10 times smaller, or you could say is 1/10 of, remember that's the same thing, 10 times smaller and 1/10 of is the same. Each place value is 10 times smaller for each step you take to the right. It is going to be really critical that from this point forward, you understand these place values. You understand that everything to the left of the decimal are wholes and everything to the right are pieces. So if I'm getting smaller as I go, that means that the thousandths place, clear over here, is a smaller place value than the tenths place. Think about this for just a minute in terms of money. This would be like having 7 dimes. This one, because it's in the hundredths, would be like having 3 pennies. So what's bigger, 7 dimes or 3 pennies? What's more or bigger? 7 dimes. That's because it's in the tenths place. This one is 3 pennies. What do you think this last one would be? Think about it for a minute. It takes 10 pennies to make 1/10 or 1 dime. Remember, it's getting 10 times smaller. So if this was a dime and this is a penny, this would mean this is a piece of a penny. 1/10 of a penny. That's how small this place value is. And it doesn't matter what digit is in it, it's still a pretty small place value. The further you go, the smaller the place values get, or the smaller the pieces get. I could have a lot of them, which would add up to a lot, but the piece size is getting smaller and smaller and smaller. So maybe like this, 1/10, 100th, 1,000th, smaller. Okay, so it is really important as we're making this key right here that we put this decimal in between. I'm going to put it on the line right here to separate the wholes from the pieces, and I'm going to make a rectangle around it. When we are saying a number that has a decimal in it, we say the word and. So we have thousands, hundreds, tens, ones, and we're going to pick up the blue. We're going to continue making our key. We reviewed this before, but the place value just to the right of the decimal is the tenths. Sounds like tens, but it's 10 with a THS. The THS is going to represent pieces, so tenths. And then our purple. You should know this place value as well. Go ahead and say it to yourself. The purple is the hundredths. So again, it's very similar. It looks like this. See how I have tens and then hundreds, tenths and then hundredths, but you have to add the THS. And then lastly, that pink one is the thousandths. This should be a little bit of a review, especially up to the hundredths, but maybe the thousandths might feel new to you. It's just one more place value to the right. This is the thousandths. So if you kind of take a look at it, if you were to group the ones and the decimal together, as in the ones place, it becomes this, you're doing like this reflection as you go. So here's an example. If the ones and were together, look, I'm going to cover it with my fingers, then you would have tens and tenths, hundreds, hundredths, thousands, thousandths. So think about what number would come ahead of the thousands if you were getting bigger. It would be the 10,000s. So what do you think the number would be down here if you were getting smaller? It would be the 10,000ths. So that it keeps repeating itself as you go. Only the difference is you add the THS to represent pieces. So again, all of these, all of those colors are wholes. W-H-O-L-E-S. Those are all wholes, whole numbers. And all of these are pieces, just like fractions. Decimals are just like fractions. Okay, so something that I want to do is kind of mimic this movement from place value to place value. We oftentimes do this. See how it says 10 times bigger for each step you take to the left. I want to kind of show that a step is like this. 1, 2, 3. We usually indicate that with an arrow. So show me that stepped placement over here as you step 1, 2, 3, and you can go further. That's why the arrow's there, so that it keeps going. Okay, so as we talk about moving place values, that is oftentimes represented in math is a scooping motion under the number to get to the next place value. That's what that represents. All right, what we're going to be doing next is talking, now that we know all of these numbers, we're going to practice saying this number out loud. Remember, you do not put the word and in a number unless you see a decimal. So here's an example of what some adults say. They would say this number is 4,692. Did you hear that? I snuck in 2 ands that shouldn't be there. 4,692. And this is where a lot of 5th graders have a hard time pronouncing the number. So I want you to look at it. Don't be confused and don't just say and 735. You don't say the digits. You just look at what that number would look like. For example, if the decimal wasn't even there, what number would you say that that is? I'm having a hard time covering up all of it. You would just say 735. So you just say the number you see. And remember, with these numbers, since it's the very end of the number, you say the place value it ended in. So this would be and 735 thousandths. Again, 4,692 and 735 thousandths. What if it ended like this? What if the 3 was my last digit? Let's practice saying that. 4,000, you better be saying this with me. Let's start again. 4,692 and, what number do you see? 73. And what place value did the 3 end in? Hundredths. 2 over is the hundredths. Again, 4,692 and 73 hundredths. Let's practice this number. What if it ended in this with just the 7? What place value is that? It's the tenths. Here we go. 4,692 and 7 tenths. So don't be confused by seeing lots of digits here. You say the number you see and then just end in that place value. Last time we're going to say this number super fast. 3, 2, 1. 4,692 and 735 thousandths. Hopefully you got that. Okay. So what we're going to be doing next in this lesson is talking about how numbers can be represented in lots of different ways. So we're going to be going over standard form, word form, expanded form, and expanded form using powers of 10. We have a lot to do today, so please make sure that you click on the next video in order to continue your journal.